Order of operations. Definition of exponent. An exponent tells us how many times a number is multiplied to itself. The base is the number that is multiplied to itself, and the exponent is the number that tells us how many times that number will be multiplied to itself. So if I were to evaluate this 3 to the 4th power, what that means is I'm taking 3 times 3 times 3 times 3. The next definition is a square of a number. And what a square of a number is if you have a number n and you square it, you have an exponent of 2, it means that I'm multiplying it to itself 2 times. So a square is a number that is multiplied to itself 2 times. So now a square of 5 would be 5 times 5, which would equal 25. So now this 25 is known to be a perfect square, and it's a perfect square of 5. So when we talk about some perfect squares, if I were to do it in numeric order, my first perfect square would be 1, 1 times 1. My second perfect square would be 4, 2 times 2. My third perfect square would be 9, 3 times 3, 16, 4 times 4, 25, 5 times 5, and so on. So we can find our perfect squares by going in numeric order and taking the number and multiplying it to itself 2 times. The square root is the inverse process of squaring a number. So if I want to know what the root of a perfect square is, I would square root it. So if I took the square root of 25, that would be 5, because I am trying to find the root of what 25 was. So since 5 squared equals 5 times 5, and it equals 25, the root is 5. So when I do the inverse of a square, it would be the square root, and it would come out as the base. So when we talk about order of operations, you want to go in the order of first working with parentheses, roots, absolute values, any type of grouping symbol in mathematics. If there's operations inside the grouping symbols, you want to get it so that it's one number. So the first thing in order of operation is to get the grouping symbols to be one number. Now, key note with order of operations is you always want to work from left to right. Once the grouping symbols is one number, then you would work with anything that has exponents. So if you have an exponent, that's the next step in order of operation. Then you'll work with multiplication and division. And multiplication and division will work from left to right. And it's very important that you work from left to right, because if you don't, sometimes the answers are different. But it's always based on working from left to right. And then lastly, if there's addition or subtraction, you'll be doing that, and again from left to right. So let's do an example here. So when we're doing evaluation here and we have parentheses around a negative number and it's raised to a power, well, what that means is that whole thing gets multiplied to itself that many times. So in this case, I have a square. So the square of parentheses negative 8 equals parentheses negative 8 times parentheses negative 8. And because I have a negative times a negative, I'm going to end up with a positive answer, and we get a positive 64. So when I'm evaluating something and it's a parentheses with an exponent, you're taking that and multiplying it to itself that many times. So if you see something like this with no parentheses, well, what that means is I'm taking the 8 and squaring it, not the negative. So when I do this, I really have a negative 1 being multiplied to that 8 squared. So when I do this in order of operations, I have to do that square first because it has an exponent, so I end up doing the square, which is 64, and then I would do the multiplication of that negative 1. So you see that we end up with a negative 64 when there's no parentheses around the number. So be really careful noticing the difference between when there's a parentheses and an exponent and when there's no parentheses and exponent. They mean two different things. So it's very important to make sure that you're using order of operations for even small evaluation processes like this. So here's an example. It's an order of operation problem, and you want to be careful. You always have to think, what do I need to do first? And in this case, I have multiplication and I also have subtraction, but the multiplication has to go first here. So when I do this, I have to do that multiplication first. So I'm just bringing down the 3, and I'm going to multiply the 4 times the 8. So I get minus 32. And then I can do the subtraction. So now I can do the addition and subtraction, and my solution here would be a negative 29. So be very careful whenever you're evaluating arithmetic type problems. You want to make sure you're thinking of order of operations. Pause and try. So again, you have to do that division first. So I'm going to bring down that negative 8. When I do that division, I end up with a minus 8. And now I need to do the arithmetic with the subtraction, and it's same sign, so I add and keep the sign. My solution here is a negative 16. So this next example is a multi-step order of operations. Now with the multi-step, whenever you see any type of grouping symbols, you have to work with them first. So in this case, I'm going to get the parentheses to be one number. So I'm just bringing down what I have in front. So I have the 2 times 7, I'm bringing that down, and I'm going to do the 10 plus 2 to get that to be one number. So I have a minus 12, and I'm bringing down the divided by 3, and then I'm doing that 2 minus 5, and because it ends up being a negative and I have a minus on the outside, I'm leaving it in parentheses. Be careful because that's my double negative. So be careful when you're doing the evaluation that you notice what's going on the outside also. So now the next step is to do that multiplication and division, and you always want to work from left to right. So I'm going to have the 7 times 2, and that's going to be 14, and then the 12 divided by 3 is going to be minus 4, and that double negative is going to change to a plus. So it's important that you work from left to right and think of the different rules that apply. And now it's addition and subtraction. From left to right, I end up getting 14 minus 4 is 10, and then plus 3, I end up with 13 as my solution. Pause and try. So I'm working in the parentheses first. I end up getting a negative 12 divided by 3 plus 4, and then I'm doing the multiplication and division. I end up getting 36 minus a negative 4. I kept it in parentheses, bringing down that plus 4, and then I see that double negative. Always keep in mind double negatives change to positive. So I end up with a 40 plus 4, so my solution here is 44. Now this next one, notice that I have grouping symbols, and then on the outside of the one grouping symbol I have an exponent. So it's very important for order of operations that we follow the steps it takes. So the first thing here is grouping symbols. Always the grouping symbols, and in this case parentheses. Get it to be one number. So I have the 16 divided by, and then I have a negative 2 squared. 8 minus 10 is a negative 2. I'm leaving it in parentheses because if you don't, we have a difference between the parentheses negative 2 and a negative 2 with the square on it. And then I have minus, and then notice 3 minus 6 is a negative 3. So I'm leaving it in parentheses times 2. So it's important that we work order of operations and think step by step as we're working it. So the next step in order of operations is to do exponents. So I have a negative 2 with parentheses squared. That means that I'm squaring the negative also. So I end up getting 16 divided by positive 4. And then I have minus negative 3 times 2. And now I'm going to do the multiplication and division from left to right. I have 16 divided by 4 is 4, minus, and then a negative 3 times positive 2 is a negative 6. And then I see that double negative. So that double negative is going to change to a positive, and then I do my addition here. So I end up with my solution is 10. So work step by step, solving order of operations to assure that you get the correct answer. Pause and try. So again, I'm doing the parentheses first. I get a negative 1 squared minus 2 times 2 divided by 4. I have to do that exponent. A negative 1 squared is a positive 1 minus 2 times 2 is 4 divided by 4. And then I have 4 times 1 is 4 minus 4 divided by 4 is 1. And then I have 3 as my solution. So now notice this next example has a grouping symbol with grouping symbols inside. So really we have a multi-problem, meaning I have to get the brackets to be one number before I can remove the brackets. So whatever's on the outside I'm not working with until I get the brackets to be one number. So what I do is I bring down the 3 minus and bring the bracket down and work inside doing order of operations. So inside the order of operations, the first thing I need to do is that parentheses. So I end up getting a negative 2, 4 minus 6 is a negative 2, plus 2, and it's attached to the negative 4 because when you have a number attached to something, it means multiplication. So now I'm going to have to do that multiplication. So I'm just bringing down the 3 minus and the bracket because it's still not one number. So that minus 2 is going to come down, and then I do that positive 2 times a negative 4 will give me a minus 8. So now I have minus 2 minus 8. I can do that arithmetic here, same sign, add and keep the sign, so I end up getting a negative 10. Now it's one number. So now that it's one number, I can remove the brackets, but because I have that double negative, when I remove the brackets, I have to keep that in mind, and that's going to change to a plus 10. And then I have 3 plus 10 will give me 13. So be very careful when you have grouping symbols inside grouping symbols. Pause and try. Very similar to the example, I'm going to work inside. I get a negative 2 plus 6 times a negative 2. I have to do that multiplication. I end up with a negative 2 minus 12. Notice I'm just bringing the 5 minus down. I'm not working with it until the brackets are one number. And then I have same sign, add and keep the sign. I get a negative 14. Now I see that double negative. That double negative is going to change to a plus, and my solution here is 19. So this next example has multiple things going on. And notice I have a top part of the problem and a bottom part. That line that crosses over is division. But really I have stuff that I have to work with and get it to be one number on top, and stuff that I need to work with on the bottom and get it to be one number before I can actually do that division. So it's very important that we work order of operations, and these are really two separate problems that I'm working. Remember, grouping symbols are that square root and that absolute value. So I need to get that to be one number. So grouping symbols aren't just parentheses or brackets. They're also square root symbols and absolute value symbols. So I do the square root and get that to be one number. So I have 30 minus 5 is that 25, and then I do the absolute value. I have 1 minus 9, and that's a negative 8. Now what I'm going to do is I'm going to work with the square root, and square root 25, and that's a perfect square of 5. So it ends up coming out as a whole number 5. Now keep in mind, when something is attached, that means it's going to be multiplication when it comes out. So that negative 5 is going to be multiplied to that 5. And then the absolute value, remember, of any number always comes out as a positive. So the absolute value of that negative 8 is going to come out as a positive 8, so we have plus 8. Now I'm going to do the multiplication, and I'm going to do the negative 5 times 5 is a negative 25. And remember, parentheses around that square means that I'm doing a negative 2 times a negative 2, which gives me a positive 4. And then 4 squared is 16 plus 8. And now I'm going to do the arithmetic here. Negative 25 plus 4 is a negative 21. 16 plus 8 is positive 24. And now I can simplify. So now in this case, it's not going to divide evenly, so it's really just a reduced fraction here. So my solution here would equal a negative 7 over 8. This next part is evaluation. And evaluation means to find the value of an algebraic expression by substituting in numbers into or for the variables. So the first thing you're going to do is take whatever the values that are given for the variables and plug them into the expression. Then you're going to have an order of operations. So evaluation uses order of operations. So it's very important that you understand order of operations in order to do evaluation. So here's an example. We're asked to evaluate the expression, and our expression here is that 3x minus 7y. When x equals 4 and y equals a negative 3. So they're giving me the values for x and y, and to evaluate, it means I have to take those values and substitute it into the expression. So when I do this, I'm plugging it in. And I'm using parentheses. And the reason why I'm using parentheses to plug it in is because 3 is attached to x. And that means that when I plug in the 4 into x, I'm going to have multiplication. And the same goes with the y. 7 is attached to the y. So when I plug in that negative 3, I'm going to end up multiplying. So now this is where the order of operations come into play, and I have to do, in this case, the multiplication first before I can do the addition or subtraction. So I'm going to multiply the 3 times 4, which will be 12, and then I have a negative 7 times a negative 3 is going to make that plus 21. So now I have arithmetic or addition and subtraction, so I add 12 to 21, and my solution here would be 33. So this is evaluation. Be careful with something similar to this. When you have evaluation and you have an expression where it's a negative 2y squared. So I have a negative 2y squared. Now they're giving me an x value and a y value, but there's no x value, so I don't variable in the expression, so I don't need the x value. All I need here is the y value. But when you're substituting in this y value, you're substituting in a negative 3. So make sure you use parentheses when you plug it into the y value. And notice that that exponent stays on the outside of the parentheses, because I'm squaring whatever I put into y, and I'm putting in a negative 3. And especially with something like this, that you want to make sure you're using order of operations, because order of operations means I have to do exponents before I multiply here. I can't multiply that negative 2 to that negative 3, because order of operations states you have to do the exponent first. So in this case, I have to square that negative 3, and a negative 3 squared is going to give me a positive 9. And then I can multiply that negative 2. So I multiply the negative 2 to the positive 9, and my solution here is a negative 18. So with evaluation, you always need to think of order of operation once you substitute the numbers into the variables. Pause and try. So again, I substitute the numbers in. I'm using parentheses here. I do the multiplication. It's 8 minus 10. 5 times a negative 2 is a negative 10. And then I do the arithmetic or the subtraction. 8 minus 10 is a negative 2. Pause and try. So this is a multi-step evaluation. I'm substituting in the negative 2 for A and the negative 4 for B. Make sure you put parentheses around that negative 2 with that square. Now I'm going to do order of operations, which means I have to do that exponent first. Negative 2 squared is a positive 4. Now I'm going to work multiplication and division from left to right. So I get 3 times 4 is 12 divided by 2. And then I have 12 divided by 2 is 6. Now I can do the addition and subtraction. Negative 4 plus 6 is 2 minus 5. 2 minus 5 is a negative 3. So make sure you're doing order of operations step by step. So now this next type of problem is still evaluation, but you'll see function notation. And what function notation is, it is a special symbol in mathematics used to denote a function. And the symbol f parentheses x parentheses is read f of x. So f of x, this doesn't mean that I'm taking f and multiplying it to x. It's a symbol to represent a function. So now when you're asked to find a function value and you're given f of x equals 4x minus 1 and you're asked to evaluate or find f of 2, well, notice here that f of 2, if I were to put it for the f of x, that 2 value means I want to take this f of x equals 4x minus 1 and plug 2 into the x and find what it would equal. So when you have function notation and you have f of some number, it's asking you to evaluate the function expression with that number in it. So I have f of 2 means that x equals 2. I'm going to take 2 and I'm going to plug it into the x. And then I'm going to evaluate. So I have 4 times 2 is 8, and then I'm going to have 8 minus 1 is 7. So when I find my value for f of 2 will equal 7 for this expression f of x equals 4x minus 1. So it's evaluation using function notation. Pause and try. So yes, you're going to plug in the negative 3 for the for the x value. We're going to do the evaluation. We have a negative 18 plus 7. So my f of negative 3 for this function, f of x equals 6x plus 7, will equal negative 1. So we're going to be working with simplifying expressions. And when we're talking about simplifying expressions, one property that we'll be using is the distributive property. And how the distributive property works, if we have parentheses and we have an algebraic expression in there, not just numbers, and we have a number on the outside, to clear the parentheses, we're going to need to take that number on the outside and multiply it to everything inside. So you would take the number, in this case it's variables, a times b, we would get ab, and a times c would be plus ac. So you're going to end up with an expression versus just a number. Now be careful, because when you have the distributive property and you have a negative on the outside, negatives will change signs. So if I were to take a negative a to a positive b, it would end up being a negative ab, and then a negative a to a plus c would be a negative ac. So negatives change things. So when you're looking at a distributive property, here's an example. So notice here that this is an order of operations because inside the parentheses I don't have a number plus a number. I have a variable plus a number. So I can't just simply do the evaluation here. So I want to simplify this by removing the parentheses, and to do that you need to take that number that's on the outside and multiply it to everything that's inside. So we get have 4 times y, which is going to give us 4y, and then you have 4 times 2, which would give us plus 8. So that cleared the parentheses by taking the number and multiplying it all the way through the parentheses. So be careful when you see a negative or a minus on the outside of the parentheses, because really what that means is I'm distributing a negative to everything inside the parentheses. So when you distribute a negative, it's going to change signs. So I'm going to end up doing this negative distributive, and I'm going to get a negative y, and then it's going to be a minus 2. So it's really important that you take that minus and distribute it all the way through, and it's going to change the signs. Here's one with a negative and a number. So notice when I do the distributive property, I'm going to end up with a negative 5x, and then you have a negative 5 times a minus 3. Negative times a negative will make that a plus, and it's going to be plus 15. Pause and try. So to remove the parentheses, I'm doing the multiplication. 6 times 5 is 30, and then 6 times minus y would be a minus 6y. So now when we're talking about simplifying algebraic expressions, it's important to know some common definitions. So the first definition is called terms. And whenever I'm talking about terms, in an expression, it's separated by the plus or minus sign. So when we have an example like this, our terms here would be that 7x, that plus 5, the minus 3y, and the plus 2x. These are all terms. So I have 4 separate terms in this example. Like terms have the same variable raised to the same power. So when we have like terms, they are the same, they're same variable raised to the same power. But also, too, like terms could simply be numbers, constants. So in this case, I have like terms, that 7x and that positive 2x. They're like terms because they have the same variable raised to the same power. And in this case, the power is 1. A constant is just a number. So we could have like terms just being constants. So a constant here would be a plus 5. There's nothing to change the value of 5. 7x, if I plug something into x, it could change the value of 7. So 5 is a constant. Nothing's going to change the value. And then coefficient. Whenever we're talking about a coefficient, it is the number that is multiplied by the variable in an algebraic expression. So it's the number that's attached to the variable. So in this case, the coefficient for 7x is simply 7. So the coefficient is the number attached to the variable. So when we want to combine like terms, so simplifying algebraic expressions, we're going to be combining like terms. And combining like terms mean you need to add or subtract the coefficients of the like terms. So you're always looking, again, like terms have the same variable with the same exponent, or they're constants. So in this example here, I want to combine like terms to simplify the algebraic expression. So when I'm looking for the like terms, and then I'm going to add or subtract the coefficients. So in this case, I have a 7y, I have a minus 3y, and I have a plus y. Now, really what I have here, and I'm doing this really in my mind, but I want you to see I'm taking 7, which is the coefficient, minus 3, which is the coefficient, and for that y, it really has a coefficient of 1, and it's positive 1. And now I'm going to do the arithmetic. 7 minus 3 is 4, and then 4 plus 1 is 5. And then I'm going to take it and I'm going to attach it to the y. So to simplify, to get that 7y minus 3y plus y to be one term, I'm going to add or subtract the coefficients, and I get 5y. And then I'm going to take the constants and get them together by doing the arithmetic. Positive 8 minus 1 will equal a positive 7. So I simplified this algebraic expression, this 1, 2, 3, 4, 5 terms, to 2 terms by combining like terms. Pause and try. So I'm getting this negative 7y minus 2y is a negative 9y. And then I have a 2 plus 12 is going to be plus 14. And then that negative 2y pause and try. So I combine like terms, negative 7y minus 2y, I get a negative 9y. And that 2 plus 12 is going to be plus 14. And then a negative 9x minus x will be a negative 10x. So this is the combined like terms. And again, the order doesn't matter in the way that you write your solution. You could have a negative 10x minus 9y plus 14. I just go normally in the order in which I see the variables. But the order doesn't matter as long as you have the right coefficients and the right constant in your solution. Now this next example, you notice we have to simplify, but the first thing we're going to have to do is the distributive property. And remember, when you have a negative on the outside of parentheses, that really means I'm distributing a negative 1. And it's going to change the signs of everything. So I'm going to do the distributive property here of that negative 1, and I'm going to be left with a negative 4x plus 2, or minus 2, excuse me. This next example of simplifying algebraic expressions, you're going to see that we have like terms and we also have parentheses with the distributive property. When we have distributive property, that has to go first. Now notice that we have a minus in front, and that really means that we're distributing a negative 1. So it's very important to understand that that negative, that really is a negative 1, and that needs to be distributed all the way through. So I'm going to just bring down my 3x, and I'm going to do that distributive property to clear the parentheses. So negative 1 times a positive 4x is going to be a minus 4x. A negative 1 times a positive 2 is going to be a minus 2. So now that I did the distributive property and cleared the parentheses, then I can do combine like terms. So you can't combine like terms until the parentheses is cleared by doing the distributive property. And now I can combine the like terms, which is that 3x minus 4x, and that 3x minus 4x will give me a negative x. Don't put the coefficient of a 1 because we don't see negative 1 or positive 1 in front of x. And then I'm going to bring down the minus 2. Pause and try. So you have to do the distributive property here first. So the 3y's just coming down. When I distribute, I get a negative 8y plus 10. And then I can combine the y's here, and I get a negative 5y plus 10. And this next example, I have two distributive properties that I need to do first. So you want to make sure you do the distributive property. I get the 4y plus 12. But be careful here because you have to distribute a negative 5. So it's negative 5 times y is going to be a negative 5y. Negative 5 times 1, positive 1, is going to be a minus 5. And now you're going to combine like terms. And again, 4y minus 5y will give me a negative y. And then positive 12 minus 5 will be plus 7. Pause and try. I'm going to do the distributive property here. I'm going to get 7x minus 7, distributing that negative 5, negative 10x minus 15. When I combine like terms, I get a negative 3x minus 22.